Hi everyone. Uh, so this is our first face-to-face lecture for this semester operating systems course. So with Professor Songju Lee, and my name is Taekyung Lee. I'm the TA in charge of project number 1 with TA Sujin Han. So today's lab session will be very simple and brief introduction to our course and projects. So let me start. So before, start explaining, operating system course, as all of you know, would be a very tough course in the entire EE lectures. So we would highly recommend you have already taken the EE415 programming structures for electronic engineering. And also, we expect you not taking other intensive courses. And also, you must be familiar with Linux environment and C programming language, including pointer arithmetic, array control statements, and Linux or POSIX APIs. We will not teach you these things. And of course, you should not try any kind of plagiarism or cheating, including using codes from ChatGPT. So please be aware. And also, in the lab sessions throughout this semester, we will give a brief introduction of upcoming projects. This ratio of project scores could be tentative. Project number 1 would be released next week, Wednesday, and it's about implementing threads. And also project number 2 is about user program, and project number 3 would be about virtual memory. And in this semester operating system course, you will not implement project number 4, file system. So we expect the load would be slightly easier. And also, you need a personal computer to take this course. So if you don't have any laptop or desktop, please contact us so you can access to head-on lounge machines. And also, as Professor announced, we are going to have quizzes every Monday. So that way you would, eventually need your personal computer. So that's, and also we will not have attendance check, also not for lab, as Professor mentioned, not for this entire course, but please participate, and we will not answer any questions covered in the lab, so please attend. And as we noticed, we use CampusWire for questions, which is basically English only. So our course is entirely English only for everything, for your all submissions and your quizzes and your exams. And also please post questions publicly. So please avoid posting your own code, entire code, and please ask questions in public, not asking only to TAs and instructors. And please feel free to answer any questions so any students can answer anyone's question, which would be eventually be counted in the participation points, which is 10% of your total grading. And for private issues, for example, like if you need access to head-on lounge, please contact to our official course staff email, EE415 at nmsl.cars.ac.kr. And please do not contact to individual instructors using personal emails. And our course homepage is there. So you need to check CampusWire and our course homepage periodically to get updated. And we will not use KLMS at all. And all the course materials, slides, lab sessions, recorded videos, and project documents will be uploaded in CampusWire and the homepage. And our submissions, we'll accept the submissions via Google Form. Yes. Yeah, we will not use KLMs. Yeah. And we release Project Zero, which is team assignment. So you need to set up Pintos environments, as we will explain in the following lab session today. And also you need to form a team to implement Pintos of at most 2 students. So you can work alone if you want, or you can find a teammate and submit your teammates, if there is, your name and student ID at this following Google form. You can feel free to use CampusWire to find a teammate if you want. And please, we recommend you to use Git to collaborate, but you must set your repository private. Yeah, not to expose your code to anyone else. Please be careful if you expose your code to other people, and if they use your code, the one who exposed the code could be also caught in the plagiarism, so please be careful. And also, as Professor mentioned in the last lecture, we do not accept any kind of late submissions. So this includes submitting the project. So there is no token for Pintos this semester, and we don't accept any late submissions even few seconds late. So please be aware of that.
Do we get like bonus points to work alone?
Yes. Now, typically in my courses, I encourage single person project, but because this very in place, I do recommend finding a mate. If you go solo, it will be good points, but if you don't get 100 points, if you get 60, plus 6. This is where multiple students try to matchmake for those cases. So don't automatically drop it. But I do recommend looking at and this is like, unless somebody drops, your team should go all the way. It's not like you're a free agent, I team up with this guy in project 1, then I switch to a different project. And I go solo on project 1, or just keep on moving. The other thing that we mentioned about the tourism, this happens every semester no matter how strongly we talk about it. Pintos is pretty used worldwide. There's a lot of code, so you could possibly like see it easily, maybe Google it, whatever. Right? But we do have code for all previous KAIS students who took this course, but also there's a CS course in OS who have been taking a long time, so we do have a database of all the code. The thing is, it might be hard sometimes, like you say, oh, I wrote it, but it's actually quite easily detectable. And when we have suspicious students, we invite them and we ask them to go through the code. If you didn't write it, you can't really explain it. So don't try it. Basically, you know, everybody knows it, but as soon as there's a deadline, you're stressed, days and all that. Sometimes you just lose cautious and just copy really good.
And yeah, also you might have already implemented printers in the past semesters. And if you have did implement it, please please let us know in the document you submit at the project that you or your teammates code is somewhat from your previous semester's ones. And just being curious, how many of you are taking computer science department OS course this semester? No one?
Has any of you took CS OS course? Really?
Yeah.
I actually take this semester with CS.
Okay.
So there was you already took the lecture, right? So they changed their project.
Yes, they actually I'm concerned about drafting one of the course because in the CS was course so provide the complete inputs.
I know, so we have to put it as well. So we can use that. But are you a CS major or double major or?
I'm double majoring. I'm majoring CS.
Okay, so you can't draw OS with this part. No. Okay. So if you're a CS major, because in CS, OS is the required.
Yes.
You have to take it sometime.
Yes. Okay.
So I mean, we can't force anybody to take the drop, but we do know what's going on over there in Focus here. We need to on that drop. So we know what project they're doing. We were, definitely concerned because from the CS we would get that code, and we have that code as well. So I'm a bit concerned. I mean, do you have to take both right now? Why are you taking both?
Actually, I'm just wondering about the difference of CS and EE. So CS use the cut down.
The textbook is different, but the concept you will want is different.
Yes.
I would say. So I mean, again, I can't say to take, not take. But as a professor, I would recommend you learn more things than simply adding up the credits for graduation. But that's your decision. And there are a couple other students who took CS OS. May I ask, kindly, why do you want to take this course again?
Very focused on the projects. Now stay in the OS.
So instead of me taking this, yes, you want to. Yeah. And there's another student. They can ask you. If you can speak English, I mean, try your best. Yeah. I mean, nobody speaks English perfectly. You don't.
So I was class in second year in undergraduate.
Very, very ambitious.
And actually,
It's difficult.
yes, so I took that course, but I didn't really understand philosophy. But my grade is not available for the take this course.
So again, these are your decisions, right? Now, if you had written some code back then, if you're gonna recycle it for your own project. I mean, again, I'm not gonna make you rewrite this code for you, but perhaps you might want to. But make sure you make a note of it because it's possible your code is in our database.
Okay, so please submit your team assignment by next Tuesday, 11:55 p.m. Okay.
Let's say for some reason you still can't find it, then we might announce just the visit.
Oh.
And you guys can go to
So that was for course introduction. And let me explain about Pintos briefly now. So as all of you know, Pintos is an educational operating system for x86 architecture. You might know that computer science department has modified Pintos to x64 architecture, but in this semester we will stick for x86. Pintos is developed by Ben Puff in Stanford University 20 years ago, and it supports kernel threads and also loading and running user programs. You can write your own user program which can run on Pintos, and also it supports file system. To run Pintos, although Pintos can run in native x86 CPUs, since we do not use that kind of CPUs anymore, we should use simulators such as Box or QEMU. And so why we use Pintos for operating system cores? Is that it is very important to implement a variety of concepts in operating systems, such as threads, which is project number 1, processes, project number 2, memory management, project number 3, and file systems, which was project 4. And so you will implement them through Pintos. And however, existing commercial operating systems like Linux are very large, like 1 million number of lines of code, and which most of them are device driver codes, which is very redundant for you to learn operating systems for now. And also compiling Linux takes about an hour, which is not appropriate to learn operating systems. In contrast, Pintos is very simple. Very simple and easy to understand compared to Linux, and easy to compile. It takes a few seconds to compile. So Pintos is a very good system for you to learn operating systems. So in this week, like until next Tuesday, you have to set up your own environment to run Pintos. There are 4 available options you can choose. First one is utilizing virtual machines like VirtualBox. And second option is using Windows subsystems for Linux, WSL, for of course for Windows only. And you can also install Pintos on Mac. And if you're using WSL, or if you have like native Linux machine, you can install directly on the Linux. So as I explained before, Pintos is based on x86 architecture, and we should use QEMU emulator to run Pintos to simulate x86 architecture, which will be run on the host machine operating system. So that is basic execution of Pintos, and you have to install QEMU and other underlying required packages, and you will modify Pintos code itself and run them on the emulator. So again, installing Pintos has 4 options, but WSL, Linux, and Mac OS configurations might be slightly different among devices or their versions. So we will use our pre-configured virtual machine to grade your projects. So it's up to you to choose what configurations, but you have to test your own Pintos program on the virtual machine to make sure that the program runs correctly in the test environment. Okay. However, there is a small problem about virtual machine. If you're using M1 Mac device, VirtualBox would have problem, compatibility issue for now. So please visit us at the end of this today's lab session, so we can discuss how to solve that issue, for example, using Hedong Lounge machines. Anyway, if you're not using M1 Mac, that's a good news, and you can just download the VirtualBox at this website and install them. And we already uploaded the virtual machine image on the Google Drive, and you can feel free to download them and run with the VirtualBox program. And this is the ID and password for the pre-configured Ubuntu. Yeah. And it also includes the Pintos project files to start project number 1. And if you don't want to use VirtualBox because they are too laggy and slow, you can try another options. You can try Windows subsystems for Linux. That's very fast compared to virtual machines. And you can just install WSL and install Ubuntu. We recommend Ubuntu 18 version, and you can install and run them. And after installing WSL, or if you're using Linux native machines, you have to install QEMU, like, yeah, these commands. And you should make a link of QEMU, and you can just follow these instructions. They're very simple. And if you're using Mac OS, the setting might be a little bit harsh, but we provide the instructions here. So please let us know if you have any problems with installing Pintos in Mac OS. There might be some errors regarding GCC or some libraries. So we provide the solutions here. And for Pintos, if you're not using the pre-configured image file for virtual machines, then you should manually download this Pintos tar file from our Google Drive link and unzip tar and set up the Pintos environment. Yeah, very simple. And after configuring that all, please try make and run Pintos until the end of Project Zero's deadline, so that you can start implementing Pintos at next Wednesday. Yeah, please test your Pintos with this. Let's comment here. And you will see the screen like this image on the right side. Okay. Some troubleshooting guidelines for Mac OS is also available. And also, you might have GCC version issue, and you can refer to that. So that is very simple, right, to install Pintos. And if you need more information about Pintos, Pintos file structures, or what you should look, please refer to Project Zero document and Google Drive link for virtual machine files and Pintos project files are already available. And again, team assignment is due next Tuesday. And yeah, please don't be late. And we will introduce Pintos project number 1 threads at next week lab session at same time, same location. Yeah. So that's all for today's lab session. Do you have any questions?